So in this video, we're going to be covering topic 7.1, using trigonometry with right triangles. We're going to accomplish two goals today. So our first goal is that we can use sine, cosine, and tangent, secant, cosecant, secant, and cotangent to find the missing side of a triangle. And then we can solve a triangle. I can solve a triangle using a 30, 60, 90, and 45, 45, 90 triangle. So what you don't know about trig yet is that we actually have three more trig ratios. And what these trig ratios are the reciprocals of our sine, our cosine, and our tangent. So cosecant, which we abbreviate CSC, is the hypotenuse over the opposite. And it's the reciprocal of sine. I don't need to spell it. We're just going to use sine. And then secant is the hypotenuse over the adjacent, which is the reciprocal of cosine. And then cotangent is the adjacent over the opposite, which is the reciprocal of tangent. Okay, so if you look over here, we've got our SOHCAHTOA acronym, which is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then I made this up, but I will say that this is SOHCAHTOA's girlfriend, Chosha Cow, and this means that the cosecant is the hypotenuse over the opposite. Secant is the hypotenuse over the adjacent, and cotangent is the adjacent over the opposite. And notice that these are directly lined up with their reciprocals in that little saying. So what we're first going to do is we're going to write each ratio in this first example. So here's my reference angle. I know that the cosecant, I'm going to label the triangle again, just like we were doing. So the opposite is across from the reference, across from the 90 is the hypotenuse, and whatever's left is the adjacent. Cosecant is the hypotenuse over the opposite. So I would do 13 over 12, and we're not worried about improper fractions. Secant is the hypotenuse over the adjacent. So I would do 13 over 5. And then finally, cotangent is the adjacent over the opposite. So I would do 5 over 12. Why don't you take a minute, pause the video, and then try example 2 on your own, and then unpause it to check it. Okay, in example 2, again, I would label. So here's my reference angle. Across from my 90 is hypotenuse. Across from my reference angle is opposite. And what's left over is adjacent, or what's next to my reference angle. Cosecant, again, is the hypotenuse, 5, over the opposite, 3. Then secant is the hypotenuse, 5, over the adjacent, 4. And then finally, cotangent is the adjacent 4 over the opposite 3. In this next example, we're going to evaluate all 6 trig functions. So we're going to do the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of the angle theta. And I'm not sure if I mentioned this before, but this is just a Greek letter, theta. So it's just another way to name an angle, and we typically use that in trigonometry. So what's the only difference between these examples and the previous ones is we're missing a side, so we need to use the Pythagorean theorem to get that missing side. So I'm just going to put an X there temporarily. And of course, I'm going to use my Pythagorean theorem, which Mrs. Ballard likes to call legs squared plus legs squared equals hypotenuse squared. In this case, I have the hypotenuse, and one of my legs, I have the opposite leg. So I'm going to go 15 squared plus x squared equals 17 squared. So 15 squared is 225 plus x squared. I believe 17 squared is 289. And then we're going to subtract those two. So I could, if I wanted to, I could get Desmos out. And I could use my calculator, just double check 17 squared. It's definitely 289. I need to do 289 minus 225, and I get 64. So x squared equals 64. I'm going to undo the square by taking the square root. Remember, in geometry, we don't put a plus minus, we just put a positive. Square root of 64 happens to be 8. So I know that this side is 8. And now I'm going to find my 6 trig functions. And I didn't give them to you. You have to write them out. So I want to not just do the new ones we just learned. I'm going to do sine, cosine, tangent. And then I'm going to put their reciprocals over here, cosecant, secant, and cotangent. So sine is opposite, which is 15, over hypotenuse, which is 17. Cosecant, I could just flip that, 17 over 15. Cosine is adjacent 8 over hypotenuse 17. Secant, I'm just going to flip it, 17 over 8. And then tangent is opposite 15 over adjacent 8. Cotangent, I would flip it, 8 over 15. Now, example 4 isn't quite as pretty as example 3. We're going to use our Pythagorean theorem again. So again, I'm going to do my leg squared plus leg squared equals hypotenuse squared. I know that across from the theta is the opposite. This is the adjacent, and that's the hypotenuse. So one of my legs is 5, so I'm going to go 5 squared plus, I don't know what this is, I'm going to call it x. So x squared equals 5 square root of 2 squared. And notice my squared is on the outside of that. So 5 squared is 25. I'm going to distribute this in. So that would make it 5 squared is 25. And remember, a square times itself. So square root of 2 times square root of 2 is what that means, would be square root of 4, which would be 2. So really what happens is when I square a square root, they cancel each other out. So this would just be 2. So I'm going to do one extra line of algebra here. 25 times 2 is 50. And then I'm going to move the 25 to the other side by subtracting. So 50 minus 25 is 25. And I'm going to undo the square by taking the square root. So x equals 5. All right, I'm ready to do my 6 trig ratios. So sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Wouldn't be a bad idea right now to pause the video and try those 6 ratios on your own. Okay, we're going to check them. So I'm going to do the opposite over the hypotenuse. And if you didn't get these all the way exactly the way I'm going to do them, that's okay. Just fix them up. So I've got 5 over 5 square root of 2. I'm going to go ahead and flip this, but I am going to need to simplify that a bit. So I didn't really leave myself a whole lot of space for that. I know my 5s are going to cancel. I'm going to be left with a 1 in the numerator. And then I have to do what I call rationalizing the denominator, which we've done before. We're going to multiply top and bottom by that square root of 2. So I would end up with across the top, square root of 2, and then I take a shortcut on the bottom. A square root times itself is just going to be the number underneath, just like we did here. Square root of 2 times square root of 2 ends up being 2. Here, on this one, I'm just going to cancel my 5s, and I end up with square root of 2. I'm going to move these down a little bit because I did not leave myself enough space. All right, if you need more space, use that left-hand column. Okay, so the cosine of theta, I'm going to do the adjacent over the hypotenuse, which in this case happens to be exactly the same thing. If that is the case, I don't need to see any of this work. Just go ahead and write what the answer is. And then for the secant of theta, make sure you go back to what it was before we did any simplifying when you do your flipping. So I'm going to go 5 square root of 2 over 5. Those cancel, and I'm left with just square root of 2. And then finally, I'm going to squish tangent in here. Tangent is the opposite 5 over the adjacent 5. Cotangent, when I flip it, is going to be 5 over 5, and both of those reduce to 1. Next, we are going to look at this is really the same thing we've been doing, but we're going to look at it from a slightly different approach. So it says, let theta be the acute angle of a right triangle. Find the values of the other 5 trig functions of theta. So the first thing we're going to do is we're going to take whatever we can get for free and we're going to flip the reciprocal. So I know the reciprocal of sine is cosecant. So I'm going to immediately get cosecant is 7 over 4, and now I only have 4 more to worry about. So what I'm going to do is I'm going to draw a triangle. In my triangle, I know sine is opposite over hypotenuse. So on my opposite, I'm going to put a 4, and my hypotenuse, I'm going to put a 7. And now guess what? We get to use the Pythagorean theorem again to find that missing side. So I know my legs are 4 and x. I'm going to make 4 squared plus x squared. My hypotenuse is 7. So that's hypotenuse, opposite, adjacent. All right, 4 squared is 16. 7 squared is 49. Let's see. 16 minus 49 would be 33, which is definitely not going to be simplified in any way. I know that it's not divisible by a square number, so I'm just going to take the square root, and I'm going to leave it square root of 33. All right, I have sine and cosecant. I'm going to find the others, so I've got to find cosine. Cosine would be my adjacent square root of 33 over my hypotenuse 7. The reciprocal of cosine is secant, so I'm going to flip the reciprocal, and I notice I have a radical in the denominator, so I am going to rationalize it. So I multiply top and bottom by square root of 33. Across the top, I get 7 square root of 33, and across the bottom, I get 33 times square root of 33 times 33 is just the 33 itself. Next, I'm going to find tangent. Tangent is opposite 4 over adjacent square root of 33. Before I flip that, or before I rationalize that, I'm going to go ahead and flip it for my reciprocal for cotangent. And then I'm going to come back over here and rationalize. So I have 4 square root of 33 over 33. Okay, we're going to try this a couple of more times. I'm going to do one more with you, and then I'd like you to pause the video after that. So we are going to, first of all, for free, I get cotangent. So I know cotangent of theta equals 11 over 6. Then I'm going to draw my triangle. So I'm going to draw my triangle, and it doesn't matter if all your triangles look exactly the same. That's okay. I know that this is going to be the hypotenuse opposite adjacent. So tangent is the opposite over the adjacent. So I put 6 on my opposite and 11 on my adjacent. And I'm going to use good old Pythagorean theorem to find that hypotenuse. So I'm going to call it x. So 6 squared plus 11 squared equals x squared. 6 squared is 36. 11 squared is 121 equals x squared. Let's see, 36 plus 121 is 157. And I don't think that that breaks down, so I'm just going to leave it as square root of 157. And remember, by breaks down, I'm trying to look for a square number that divides that. So, and it's going to look weird and ugly and messy, and that's okay. All right, so after that, we have to find the sine. Sine is opposite 11 over hypotenuse square root of 157. And then before I rationalize that, I'm going to go ahead and flip my reciprocal for cosecant. And then I am going to rationalize this 157, square root of 157 over 157. Across the top, I get 11 over square root of 157. And then 157 times 157 is 157. And then finally, I'm going to do the cosine of theta, because that's missing, would be my adjacent 11 over my hypotenuse square root of 157. I'm going to flip the reciprocal. So secant is square root of 157 over 11. This is rationalized. This is not. So I'm going to rationalize this one. And we end up with across the top 11 square root of 157 over 157. So here's a really good opportunity for you to practice this on your own. So I would take a minute. I would go ahead and pause the video and try example 7 on your own to see if you make sure you've got this. Okay, so I'm going to start example 7, and we are going to flip our reciprocal to begin with. So I know cosine is the reciprocal of secant, which is 10 over 7. And then I'm going to go ahead and draw my right triangle. I know that its hypotenuse across from my reference is opposite, and next to it is adjacent. Cosine I know is the adjacent over the hypotenuse. So adjacent gets 7, hypotenuse gets 10. I'm going to do the Pythagorean theorem to find my opposite leg. So I would have x squared plus 7 squared equals 10 squared. 7 squared is 49. 10 squared is 100. I'm going to go ahead and subtract the 49 to the other side. So let's see, 100 minus 49 would be 51. I'm going to take the square root of both sides. I know 51 doesn't break down, so I know that that opposite side is the square root of 51. Right, I'm going to go through. I have 2 out of my 6, so I'm going to go to sine next. And it doesn't matter what order you do these in. So sine is opposite square root of 51 over hypotenuse 10. Cosecant, I'm going to flip that. So I get 10 over square root of 51. I need to rationalize this. And we're going to rationalize like 1 million times so in this unit. So you're just going to get used to doing it. So across the top, we've got 10 square root of 51. On the bottom, square root of 51 times square root of 51 is 51. And then we are going to look at tangent next. So tangent is my opposite square root of 51 over my adjacent 7. And cotangent, I'm going to flip the reciprocal. I get 7 over square root of 51. That needs to be rationalized. So I have 7 square root of 51 over 51.